Asphalt, also known as bitumen, is a sticky, black and highly viscous liquid, a semi-solid form of petroleum. It may be found in natural deposits or may be a refined product. It is a substance classed as a pitch. Until the 20th century, the term asphaltum was also used. The word is derived from the ancient Greek sigma phi alpha lambda tau omicron sigma asphaltos. The primary use of asphalt bitumen is in road construction, where it is used as the glue or binder mixed with aggregate particles to create asphalt concrete. Its other main uses are for bituminous waterproofing products, including production of roofing felt and for sealing flat roofs. The terms asphalt and bitumen are often used interchangeably to mean both natural and manufactured forms of the substance. In American English, asphalt is the carefully refined residue from the distillation process of selected crude oils. Outside the United States, the product is often called bitumen. Geologists often prefer the term bitumen. Common usage often refers to various forms of asphalt bitumen as tar, such as at the La Brea tar pits. Another archaic term for asphalt bitumen is pitch. Naturally occurring asphalt bitumen is sometimes specified by the term crude bitumen. Its viscosity is similar to that of cold molasses, while the material obtained from the fractional distillation of crude oil boiling at 525 degrees Celsius is sometimes referred to as refined bitumen. The Canadian province of Alberta has most of the world's reserves of natural bitumen, covering 142,000 square kilometers, an area larger than England. Composition. The components of asphalt are classified into four classes of compounds. Saturates, saturated hydrocarbons. The percent saturates correlates with softening point of the material. Naphthene aromatics, consisting of partially hydrogenated polycyclic aromatic compounds. Polar aromatics, consisting of high molecular weight phenols and carboxylic acids. Asphaltenes, consisting of high molecular weight phenols and heterocyclic compounds. The naphthene aromatics and polar aromatics are typically the majority components. Additionally, most natural bitumens contain organosulfur compounds, resulting in an overall sulfur content of up to 4%. Nickel and vanadium are found in the NLT 10 ppm level, as is typical of some petroleum. The substance is soluble in carbon disulfide. It is commonly modeled as a colloid, with asphaltenes as the dispersed phase and maltenes as the continuous phase, and it is almost impossible to separate and identify all the different molecules of asphalt, because the number of molecules with different chemical structure is extremely large. Asphalt bitumen can sometimes be confused with coal tar, which is a visually similar black, thermoplastic material produced by the destructive distillation of coal. During the early and mid-20th century, when town gas was produced, coal tar was a readily available byproduct and extensively used as the binder for road aggregates. The addition of tar to macadam roads led to the word tarmac, which is now used in common parlance to refer to road-making materials. However, since the 1970s, when natural gas succeeded town gas, asphalt bitumen has completely overtaken the use of coal tar in these applications. Other examples of this confusion include the La Brea tar pits and the Canadian oil sands, both of which actually contain natural bitumen rather than tar. Pitch is another term sometimes used at times to refer to asphalt bitumen, as in Pitch Lake occurrence. The great majority of asphalt used commercially is obtained from petroleum. Nonetheless, large amounts of asphalt occur in concentrated form in nature. Naturally occurring deposits of asphalt bitumen are formed from the remains of ancient microscopic algae and other once living things. These remains were deposited in the mud on the bottom of the ocean, a lake where the organisms live. Under the heat and pressure of burial deep in the earth, the remains were transformed into materials such as asphalt bitumen, kerogen, or petroleum. Natural deposits of asphalt bitumen include lakes such as the Pitch Lake in Trinidad and Tobago and Lake Bermudez in Venezuela. Natural seeps of asphalt bitumen occur in the La Brea tar pits and in the Dead Sea. Asphalt bitumen also occurs in unconsolidated sandstones known as oil sands in Alberta, Canada, and the similar tar sands in Utah, US. The Canadian province of Alberta has most of the world's reserves of natural bitumen in 3 huge deposits covering 142,000 square kilometers, an area larger than England and New York State. These bituminous sands contain 166 billion barrels of commercially established oil reserves, giving Canada the third largest oil reserves in the world, and produce over 2.3 million barrels per day of heavy crude oil and synthetic crude oil. Although historically it was used without refining to pave roads, nearly all of the bitumen is now used as raw material for oil refineries in Canada and the United States. The world's largest deposit of natural bitumen, known as the Athabasca oil sands, is located in the McMurray Formation of northern Alberta. This formation is from the early Cretaceous, and is composed of numerous lenses of oil-bearing sand with up to 20% oil. Isotopic studies attribute the oil deposits to be about 110 million years old. 2 smaller but still very large formations occur in the Peace River oil sands and the Cold Lake oil sands, to the west and southeast of the Athabasca oil sands, respectively. Of the Alberta bitumen deposits, only parts of the Athabasca oil sands are shallow enough to be suitable for surface mining. The other 80% has to be produced by oil wells using enhanced oil recovery techniques like steam-assisted gravity drainage. Much smaller heavy oil or bitumen deposits also occur in the Interbasin in Utah, US. The tar sand triangle deposit, for example, is roughly 6% bitumen. Asphalt bitumen occurs in hydrothermal veins. An example of this is within the Interbasin of Utah, in the U.S., where there is a swarm of laterally and vertically extensive veins composed of a solid hydrocarbon termed gilsonite. These veins formed by the polymerization and solidification of hydrocarbons that were mobilized from the deeper oil shales of the Green River Formation during burial and diagenesis. Asphalt bitumen is similar to the organic matter in carbonaceous meteorites. However, detailed studies have shown these materials to be distinct. The vast Alberta bitumen resources are believed to have started out as living material from marine plants and animals, mainly algae, that died millions of years ago when an ancient ocean covered Alberta. They were covered by mud, buried deeply over the eons, and gently cooked into oil by geothermal heat at a temperature of 50 to 150 degrees Celsius. Due to pressure from the rising of the Rocky Mountains in southwestern Alberta 80 to 55 million years ago, the oil was driven northeast hundreds of kilometers into underground sand deposits left behind by ancient riverbeds and ocean beaches, thus forming the oil sands. History. Ancient times. The use of asphalt bitumen for waterproofing and as an adhesive dates at least to the 5th millennium BC in the early Indus Valley sites like Mehrgarh, where it was used to line the baskets in which crops were gathered. In the ancient Middle East, the Sumerians used natural asphalt bitumen deposits for mortar between bricks and stones, to cement parts of carvings, such as eyes, into place for ships ship caulking, and for waterproofing. The Greek historian Herodotus said hot asphalt bitumen was used as mortar in the walls of Babylon, as did Moses in reference to the Tower of Babel, a 1-kilometer tunnel beneath the river Euphrates at Babylon in the time of Queen Semiramis was reportedly constructed of burnt bricks covered with asphalt bitumen as a waterproofing agent. Asphalt bitumen was used by ancient Egyptians to embalm mummies. The Persian word for asphalt is mum, which is related to the English word mummy. The Egyptians' primary source of asphalt bitumen was the Dead Sea, which the Romans knew as Palus Asphaltis. Approximately 40 AD, Dioscorides described the Dead Sea material as Judaic bitumen, and noted other places in the region where it could be found. The Sidon bitumen is thought to refer to asphalt bitumen found at Hasbea. Pliny refers also to asphalt bitumen being found in Epirus. It was a valuable strategic resource, the object of the first known battle for a hydrocarbon deposit between the Seleucids and the Nabateans in 312 BC. In the ancient Far East, natural asphalt bitumen was slowly boiled to get rid of the higher fractions, leaving a thermoplastic material of high molecular weight which, when layered on objects, became quite hard upon cooling. This was used to cover objects that needed waterproofing, such as scabbards and other items. Statuettes of household deities were also cast with this type of material in Japan, and probably also in China. In North America, archaeological recovery has indicated asphalt bitumen was sometimes used to adhere stone projectile points to wooden shafts. In Canada, Aboriginal people used bitumen seeping out of the banks of the Athabasca and other rivers to waterproof birch bark canoes, and also heated it in smudge pots to ward off mosquitoes in the summertime. Early use in Europe. In 1453, Pierre Bellon described in his work Observations in 1553 that pis asphalto, a mixture of pitch and bitumen, was used in the Republic of Ragusa for tarring of ships, from where it was exported to a marketplace in Venice where it could be bought by anyone. An 1838 edition of Mechanics magazine cites an early use of asphalt in France. A pamphlet dated 1621 by a certain Monsieur de Reynes states that he had discovered the existence in large quantities in the vicinity of Neufchâtel, and that he proposed to use it in a variety of ways, principally in the construction of air-proof granaries, and in protecting, by means of the arches, the watercourses in the city of Paris from the intrusion of dirt and filth, which at the time made the water unusable. He expatiates also on the excellence of this material for forming level and durable terraces in palaces. The notion of forming such terraces in the streets not one likely to cross the brain of a Parisian of that generation, but it was generally neglected in France until the Revolution of 1830. Then, in the 1830s, there was a surge of interest, and asphalt became widely used for pavements, flat roofs, and the lining of cisterns, and in England, some use of it had been made of it for similar purposes. Its rise in Europe was of sudden phenomenon after natural deposits were found in France at Osban, the Parc and the Puy de la Poix, although it could also be made artificially. One of the earliest uses in France was the laying of about 24,000 square yards of sessile asphalt at the Place de la Concorde in 1835. Photography and art bitumen was used in early photographic technology. In 1826 or 1827, it was used by French scientist Joseph Nice for an acute PCE to make the oldest surviving photograph from nature. The bitumen was thinly coated onto a pewter plate which was then exposed in a camera. Exposure to light hardened the bitumen and made it insoluble, so that when it was subsequently rinsed with a solvent only the sufficiently light-struck areas remained. Many hours of exposure in the camera were required, making bitumen impractical for ordinary photography, but from the 1850s to the 1920s it was in common use as a photoassist in the production of printing plates for various photomechanical printing processes. Bitumen was the nemesis of many artists during the 19th century. Although widely used for a time, it ultimately proved unstable for use in oil painting, especially when mixed with the most common diluents, such as linseed oil, varnish and turpentine. Unless thoroughly diluted, bitumen never fully solidifies and will in time corrupt the other pigments with which it comes into contact. The use of bitumen as a glaze to set in shadow mixed with other colors to render a darker tone resulted in the eventual deterioration of many paintings. For instance, those of Delacroix. Perhaps the most famous example of the destructiveness of bitumen is Theodore Géricault's Raft of the Medusa, where his use of bitumen caused the brilliant colors to degenerate into dark greens and blacks and the paint and canvas to buckle. Early use in the United Kingdom. Among the earlier uses of asphalt bitumen in the United Kingdom was for etching. William Salmon's polygraphist provides a recipe for varnish used in etching, consisting of 3 ounces of virgin wax, 2 ounces of mastic, and 1 ounce of asphaltum. By the 5th edition in 1685, he had included more asphaltum recipes from other sources. The first British patent for the use of asphalt bitumen was Cassell's patent Asphalta bitumen in 1834. Then on the 25th of November 1837, Richard Tapp and Claridge patented the use of Cecil asphalt for use in asphalt pavement, having seen it employed in France and Belgium when visiting with Frederick Walter Sims, who worked with him on the introduction of asphalt to Britain. Dr. T. Lamb Phipson writes that his father, Samuel Ryland Phipson, a friend of Claridge, was also instrumental in introducing the asphalt pavement. Indeed, mastic pavements had been previously employed at Vauxhall by a competitor of Claridge, but without success. In 1838, Claridge obtained patents in Scotland on the 27th of March, and Ireland on the 23rd of April, and in 1851 extensions were sought for all 3 patents by the trustees of the company previously formed by Claridge. This was Claridge's Patent Asphalt Company, formed in 1838 for the purpose of introducing to Britain asphalt in its natural state from the mine at Pyramont-Seyssel in France, and laid one of the first asphalt pavements in Whitehall. Trials were made of the pavement in 1838 on the footway in Whitehall, the stable at Knightsbridge Barracks, and subsequently on the space at the bottom of the steps leading from Waterloo Place to St James Park. The formation in 1838 of Claridge's Patent Asphalt Company gave an enormous impetus to the development of a British asphalt industry. By the end of 1838, at least 2 other companies, Robinson's and the Bastenner Company, were in production, with asphalt being laid as paving at Brighton, Herne Bay, Canterbury, Kensington, the Strand, and a large floor area in Bunhill Row, while meantime Claridge's Whitehall paving continue in good order. In 1838, there was a flurry of entrepreneurial activity involving asphalt bitumen, which had uses beyond paving. For example, asphalt could also be used for flooring, damp-proofing in buildings, and for waterproofing of various types of pools and baths, with these latter themselves proliferating in the 19th century. On the London stock market, there were various claims as to the exclusivity of asphalt quality from France, Germany and England, and numerous patents were granted in France, with similar numbers of patent applications being denied in England due to the similarity to each other. In England, Claridge's was the type most used in the 1840s and 50s. In 1914, Claridge's company entered into a joint venture to produce tar-bound macadam, with materials manufactured through a subsidiary company called Clarmic Roads Limited. Two products resulted, namely Clarmic and Clarfalter, with the former being manufactured by Clarmic Roads and the latter by Claridge's patent Asphaltico, although Clarmic was more widely used. However, the First World War impacted financially on the Clarmic company, which entered into liquidation in 1915. The failure of Clarmic Roads Limited had a flow-on effect to Claridge's company, which was itself compulsorily wound up, ceasing operations in 1917, having invested a substantial amount of funds into the new venture, both at the outset and in a subsequent attempt to save the Clarmic company. Early use in the U.S. The first use of asphalt bitumen in the New World was by indigenous peoples. On the West Coast, as early as the 13th century, the Tongva, Louisiana and Chumash peoples collected the naturally occurring asphalt bitumen that seeped to the surface above underlying petroleum deposits. All three used the substance as an adhesive. It is found on many different artifacts of tools and ceremonial items. For example, it was used on rattles to adhere goods, at turtle shells to rattle handles. It was also used in decorations. Small round shell beads were often set in asphaltum to provide decorations. It was used as a sealant on baskets to make them watertight for carrying water. Asphaltum was used also to seal the planks on ocean-going canoes. Roads in the U.S. have been paved with materials that include asphalt bitumen since at least 1870, when a street in front of the Newark, NJ City Hall was paved. In many cases, these early pavings were made from naturally occurring bituminous rock, such as at Ritchie Mines in McFarland in Ritchie County, West Virginia from 1852 to 1873. In 1876, asphalt-based paving was used to pave Pennsylvania Avenue in Washington, D.C., in time for the celebration of the National Centennial. Asphalt bitumen was also used for flooring, paving and waterproofing of baths and swimming pools during the early 20th century. Following similar trends in Europe, early use in Canada. Canada has the world's largest deposit of natural bitumen in the Athabasca oil sands, and Canadian First Nations along the Athabasca River had long used it to waterproof the canoes. In 1719, a Cree Indian named Wapasu brought a sample for trade to Henry Kelsey of the Hudson's Bay Company, who was the first recorded European to see it. However, it wasn't until 1787 that fur trader and explorer Alexander Mackenzie saw the Athabasca oil sands and said, at about 24 miles from the fork are some bituminous fountains into which a pole of 20 feet long may be inserted without the least resistance. The value of the deposit was obvious from the start, but the means of extracting the bitumen were not. The nearest town, Fort McMurray, Alberta, was a small fur trading post. Other markets were far away, and transportation costs were too high to ship the raw bituminous sand for paving. In 1915, Sidney Ells of the Federal Mines Branch experimented with separation techniques and used the bitumen to pave 600 feet of road in Edmonton, Alberta. Other roads in Alberta were paved with oil sands, but it was generally not economic. During the 1920s, Dr. Carl A. Clark of the Alberta Research Council patented a hot water oil separation process, and entrepreneur Robert C. Fitzsimmons built the bitumen oil separation plant, which between 1925 and 1958 produced up to 300 barrels per day of bitumen using dry Clark's method. Most of the bitumen was used for waterproofing roofs, but other uses included fuels, lubrication, fabrication oils, printers ink, medicines, rust and acid-proof paints, fireproof roofing, street paving, patent leather, and fence post preservatives. Eventually Fitzsimmons ran out of money and the plant was taken over by the Alberta government. Today the bitumen plant is a provincial historic site.